Hello friends, welcome. Today we would be continuing our series of classes on speed problems. Right? So speed problems, we have looked at several classes and we have solved several problems. But one thing that is common to all the problems that we have solved so far is that we have ignored the size of the objects which are traveling. So consider this train. When you are standing on a platform, the train takes a finite amount of time to cross you. Let's say that this is you and the train is crossing you. It takes a finite amount of time to cross you. Of course, on a bigger scale, when you consider a train traveling from Bombay to Delhi, then just because these distances involved are so large that this length of train, the finite amount of time it takes for train to cross an individual person, a pole, a platform, can be conveniently ignored, right? So we have been ignoring the size of the objects themselves, for example train, in the problems so far because they have been insignificant, very small as compared to the distances which were involved. But these problems, the problems that we would be looking at today, we cannot do that. We are specifically asked about, these problems specifically ask us about the crossing of a train with a pole. Right? The time it takes for the train to cross a tunnel or the time it takes the train to cross a platform. So these problems specifically ask us, right, deal with the length of the train itself, the length of the platform itself, or the length of the bridge. So these problems, to solve such problems, you have to appeal to your sense of imagination, right? So there are two key concepts involved in such problems. One is the concept of relative speed, right, which we have been looking at. We already know how to solve problems involving relative speed when two or more objects are traveling towards each other or traveling in the same direction. We already know that. And the second thing is these kind of problems deal with objects which have definite size. So the size of the objects cannot be ignored, and very common example, a very convenient example in such problems is trains. So with that background information, now let's understand the three cases. There are only three cases. If you think about it, it's not very difficult. You just have to use your imagination. There are only three cases which these problems deal with. First is trains crossing man. So train is crossing. This I am saying this is the crossing symbol. So crossing a man or a pole, right? So this means that we can ignore the size of the second object. So the second object is insignificant in size, so we will be ignoring that and we will only be considering the length of the train in such problems. The second kind of problems involved trains crossing platform, bridges, etc. Right? So in these cases, the second thing, our platform or bridge is not moving, obviously, right? It is stationary, it will just be stuck at one place. So we can ignore the speed of this second object. The train is moving, we would have to consider its length L, let's say, and the length of the platform or bridge or tunnel we would have to consider. Right? We can ignore the speed, it is not moving, we know that, but the length has to be considered. So we will call it P. The third kind of problems involve two trains crossing each other. So trains crossing other trains. And in these problems, we have to deal with both the length of these trains, let's say L1 and L2, and we also have to deal with their individual speeds. So we can call the speeds of such, so of course, in these problems we have to deal with the relative speed. So if you go back to our last class, we know that relative speed is simply when two objects are coming towards each other, their relative speed is nothing but the sum of their individual speed. Right? So this is, let's say S1, this is S2. So relative speed in this case is S1 plus S2. In the second case, when the two objects are moving in same direction, the relative speed is nothing but the difference between their individual speeds. Of course, we will only take the positive sign on this one. So now let's understand, let's develop some imagination, some intuitive idea about how to go about solving these three cases. So the first case is very simple, extremely simple. This is the pole, it is stationary, and this is the train which is crossing the pole. How much distance the train has to cover to cross this pole? You can see that the distance starts from the front of the train and the crossing is completed when the back of the train is aligned with the pole. The total distance covered is equal to the length of the train itself. So very simple, right? So in this case the total distance is equal to L. What happens in the second case? Let's say that we have a train and this is crossing a platform. The crossing starts at this instance and the train has to cross this entire platform. It has to come here, right? It has to come here. The front of the train has to come here, but the crossing doesn't end here. The crossing ends when the back of the train is aligned with the end of the platform. So what is the total distance covered? Look at the front. Look at the engine. It has moved from here. It has crossed the, only consider the engine, okay, only focus on the engine. The engine has started from here, from the end of the platform, it has moved to the front of the platform, therefore it has moved a distance of P plus the crossing doesn't end here. What is the additional distance the train has to cover? It has to cover a distance equal to the length of the train itself, and at that moment the crossing would be complete. Therefore in this case the total distance is P plus L. The speed in both of these cases is equal to the speed of the train or speed S, that is the speed involved. So these two cases extremely simple. Solve these problems. If these problems come in your examination, definitely attempt it, solve it, you will get 100% marks. The second kind of problem, the third kind of problem is a bit tricky. It involves two trains which are either approaching each other or which are going in same direction, right? So in second case one train is overtaking the other train. In the first case the two trains are approaching each other. Let us see what is the, so speed we know when the two trains are approaching each other, we already know the speed in case of, so we will divide it into two cases, approaching and overtaking. So in case of approaching, the speed becomes S1 plus S2, which we already know because they are in relative speed is sum of their individual speeds. What is the total distance? The total distance, the crossing starts at this instant and the crossing ends when the backs of the two trains are aligned. What is the total relative distance covered? The total distance covered, let's imagine this train to be stationary, okay, it is not stationary, but let's imagine, then this train has to move from here until here. What is the distance it has covered? It has covered a distance equal to the length of this train plus the length of this train, right? So the engine has moved from here, this is the length of the smaller one we have covered, and then further the engine has moved length equal to length of the bigger train. Therefore, the length covered is L1 plus L2, sorry. In case of approaching, the length covered is L1 plus L2. Now let's see what happens in the case of overtaking. When the two trains are overtaking each other, the overtaking starts when the engine of this train is aligned with the back of the other one. Let's say that the shorter one is faster, so the shorter one would be overtaking. So this train overtaking starts like this, okay, and of course we know the speed in this case would be S1 minus S2, the difference between the individual speeds because they are going in same direction. The total distance which this train has to cover is equal to this distance, this is the relative distance this train has to cover, it is equal to this distance, the distance of the longer train, plus it has to complete the overtaking, it has to move a distance, a further distance equal to the length, its own length. Therefore, the total distance covered is again equal to L1 plus L2. So we have demystified, we have simplified even the third case, and now you will be able to solve all such problems very simply. Okay, just remember these concepts. The length is always added, the relative speed is not a new concept, it remains the same as we have discussed in the last class. So with that information, let's start our solving the first problem, our first problem. Let's solve that one. Here we have a train which is of length 300 meter, and first case is that it crosses a pole in 8 seconds. So it takes only 8 seconds to cross a pole. We already know the length, the distance the train has to travel to cross the plane. Okay, so just imagine these things in your mind. Just imagine, like we have demonstrated here. Just keep these in your mind and imagine how things are happening in your mind. You should be able to imagine. So there is a pole. This train comes and it crosses the pole. What is the total distance, let's say, the engine of the train has to cover to complete this crossing? We know it is equal to the length of the train itself. Therefore, the speed becomes 300, which is the length of the distance covered, divided by 8. It took 8 seconds to cross this pole. Now it is asking us how long will it take to cross a platform. So again we take the same train, and this is the platform, and then the crossing would end, right? This is when the crossing starts. The crossing ends when the back of the train is aligned with the end of the platform. So what is the total distance the engine or this whistle has covered? It has covered a distance equal to the platform plus a distance equal to the length of the train itself. P plus L, we already know that this platform is 600, this is 300, total distance covers becomes 600. What would be the time taken? It is asking us how long will it take. What is the time taken? Time is distance by speed. Very good. So it is becomes 600 divided by, so the total distance is 600 plus 300, sorry, in the second case, which is equal to 900. 900 divided by 300 by 8. Notice I haven't simplified this yet. I will simplify it. I always say simplify all the fractions towards the end, delay the simplification. This is the reason, because things would cancel themselves as we add numbers, and some of the numbers would cancel themselves. So 300 and this 8 this becomes 24 seconds. Right? Very simple problem, not a lot of mathematics. Always attempt such problems. Right? Just keep the concepts clear in your head, clear in your mind, and always sort of remember this demonstration that we just did. Keep that and imagine that. So now moving on, this is the second problem. Here we have, instead of a pole, we have a milestone. But the things are very simple again, because the milestone also we can ignore its size and we only have to consider the size of the train itself, right? In the first case. In the second case, we have to consider both the size of the milestone, both the size of the first and the second train. Right? So that is the second case. The first scenario only talks about the milestone. So the train is 120 meters long, that is the distance it has to cover to cross the milestone, and it covers this distance in how much time? 12 seconds. So what is the speed? Speed is equal to distance over time, basic formula. So speed becomes 10 meters per second. What is the, now this is the, this speed comes from the first scenario. Let's look at the second scenario and see what happens. The second scenario, let's assume the speed of the second train to be s. What is the relative speed? They are traveling in opposite direction. So relative speed is sum of their speeds. Now this is the relative speed. What is the total length? These two trains, total relative length, these two trains have to cover to cross each other. We know it is L1 plus L2. Therefore total distance becomes 120. The second train has the same length plus 120, that is 240. What we know the time in the second case in this crossing is 8 seconds. Therefore time is again distance over speed, which is s plus 10, and we know this to be 8. If you simplify this, s would come out to be 20 meters per second. Again, very simple problem, right? I mean, as long as your concepts are clear, these problems are not very difficult. So moving on, this is our next problem. Here we have a lady named Piku, and she is observing something. Maybe her house is near a railway station, or house is near a railway track, and she is able to observe a few things. So what does she observe? She observes that there are two trains. One of them is coming from Delhi and the other one is coming from Bombay. The two trains are of course going in opposite direction. We know that because one is coming from Delhi, the other is coming from Bombay. So that's implied. The first train took 8 minutes to pass her. So her means she is standing and the train is crossing. So her size we can ignore, right? So that is completely ignored, but the size of the train we have to take into account. And of course, in the first case we have been given, right? In one case we have been given the size of train to Bombay we know it to be 150 meter. So I will write down two things here, Bombay and Delhi. I'll just write these two things down and we'll put all the information. The length is 150 meters. We don't know this length, the Delhi train length, so we'll assume it to be L. What else do we know? The Delhi took 8 minutes. So this took 8 minutes. The train in the opposite direction to Bombay took 12 minutes. This took 12 minutes. What is the speed? It is 150 divided by, that is the distance. The distance travelled to cross Piku, the train had to travel a distance equal to length of the train itself, which is 150, and it was able to do that in 12 minutes. So its speed becomes 150 by 12 meters per minute. So remember, I am keeping the units unchanged. I am not converting this minutes to seconds. So this remains meters per minute. In this case, the speed becomes L by 8 meters per minute. Again, we'll keep the unit in minutes itself. When the two trains are now traveling towards each other, their speeds would get added. Their relative speed would be the sum of their individual speeds. So their relative speeds become, I will write it here, 150 by 12 plus L by 8. This is the total speed. And what is the total distance this train has to travel? For two trains to cross each other, the total distance they have to travel is sum of their lengths. This is the relative distance they have to travel. So it's 150 plus L, that is the total length, and we know this to be equal to 9 minutes to pass each other. To completely cross each other, it is taking them 9 minutes. Of course, since we have kept all the times in minutes, I will just keep this in minutes itself. This is also in minute, this is minute, this is minute, and the lengths we have kept in meters, so I don't have to change any of the units, right? So if you simplify this, you will get 150 plus L is equal to 9 into 150 by 12 plus L by 8. Right? You can simplify it further, you will get L is equal to 300 meters. Again, very simple problem, right? You just have to keep your concepts straight, right? We have to just focus a little bit, just use a little bit of imagination. So moving on, this is another problem, again very simple problem. We have a train which is travelling at the speed of 96 kilometers per hour. Now here the problem is that one of the units is given in kilometer per hour and the second unit is given in terms of second. So this is given in terms of second. So of course we will have to do some kind of unit conversion. So let's convert that 96 kilometer per hour to meters per second. So we can do that. We already know how to do it. So if we do that, it comes out to be this 0 would cancel. This comes out to be 960 divided by 36. If you simplify it further, you will get 80 by 3 meters per second. Right? So this is the final speed of the train. Now what are we being told? We are being told, let's say that this is the start of the tunnel. We are being told that the train takes 3 seconds to completely cross this starting, that is to go inside the tunnel. So this starting is just a line, it is just a line, so we can ignore its length. We don't have to consider the length of the tunnel at all in the first case. The train takes a total of 3 seconds to go completely inside. That is what the first thing is telling us. It takes 3 seconds to enter the tunnel. To completely go inside, it takes 3 seconds. So what is the length of what is the distance the train has to travel to completely go inside? It has to travel a distance equal to length of the train. Therefore, the length of the train becomes distance is equal to speed, which is 80 by 3 into time, which is 3 seconds, 80 meters. And what is the length of the tunnel itself now? What other thing we are being told? We are being told that it takes this train a total of 30 seconds to come out. Right? So further it takes a distance of 30 seconds to emerge out. So from here, this is, let's say this is the end of the tunnel. The train is inside, it took it 3 seconds to go inside, and thereafter it took from this position to this position. Right? Notice the end of the train has travelled from starting of the tunnel to the end of the tunnel. That is, the train has travelled a distance equal to length of the tunnel itself, and this it was able to do in 30 seconds. Therefore, again the length of the tunnel, we have been calling it P, becomes 80 by 3 into 30, which is equal to 800 meter. Right? 30 seconds more, right? That is the key here. From once it is inside, it took it 30 more seconds from this configuration to this configuration to come out. Right? That is to traverse the length of the tunnel. And again, this is the answer. Again, very simple. Right? If you use your imagination, if your concepts are straight, very simple problems. You should definitely attempt this. Moving on, here we have a length of a bridge which we have to find out. We have been calling the lengths of bridges and platforms P, and we'll do the same, which a train 130 meter long and travelling at 45 km per hour can cross in 30 seconds. What is the total distance the train has to cover? We know that 130 plus P, and it has to do that in 45 km per hour. So its speed, we can convert it again to kilometer per hour, will convert to meters per second. We'll have to do that because this unit is in seconds. So we'll convert kilometers per hour to meters per second. So we did that. Okay, and this length of P we have to find out such that it takes this train a total of 30 seconds. Right? So if you solve it, 130 plus P is equal to 30 into 450 divided by 3600. Now you can solve it. The P would come out to be 245 meters. That's the answer, right? There is only one variable involved in this equation. You can simplify it. Again, very simple problem. Moving on, in this problem, we have a 300 meter long train. We have already been told that it crosses the platform in 39 seconds. The second thing that we are being told is it crosses a signal pole in 18 seconds. So since all the units are in seconds and meters, we don't have to do any kind of transformation. We only have to find out the length of the platform. So first thing we know is to cross the pole, it took 18 seconds. So what is the speed? Speed is it will have to traverse a distance of 300 meters divided by 18. That becomes the speed. The second thing, we are being told that to cross a platform of length P, what is the distance the train would have to travel? P plus 300, and to traverse this distance at this speed, this is the speed of the train, it took how long? It took 39 seconds. Right? So this is our equation. We can solve for P and you can do that yourself. The P would come out to be 350 meters. Again, very simple. Now we'll deal with a relative velocity problem, but in this case the relative velocity is involved is not with respect to another train but with respect to two people. Oh sorry, with respect to a person, with person in another train, not two people. So there is a train and there is another train right here, and there is a person sitting inside the train. So that is the key here. This person is observing this train and this train passes him, right? A man sitting in the slower train in 9 seconds. Right? So the faster train crosses the slower train, they are going in the same direction, and in this man sitting in the slower, so there is a man sitting in the slower train and it is observing, it is seeing that the train crosses me. The faster train came and went ahead in 9 seconds. So the key here is that the man doesn't have a length. We can ignore the length of the man completely. How long does the train take to pass? The man would observe the front of the train, and then slowly and gradually the man would observe the back of the train. So this is dependent, this crossing is dependent only on the length of the faster train. That is the key here. The length, just to confuse you, right, all this has been written, but the length of the slower train does not come into the picture, because there is a man sitting in the slower train and everything is with respect to that man, and the man doesn't have a length. Therefore, the only length which comes into this problem is the length of the faster train, and that is something to remember. Now, what is the relative velocity of the two trains? They are going in the same direction, so the relative velocity would get subtracted. So it would become 40 minus 20. Now, of course, this is in kilometers per hour and this is in seconds. So we will have to do some fudging here. So if we convert it, this becomes 20 divided by 3600. You can also do it by 5 divided by 18. You can also do it that way, but I always like to do it this way, so that I have to remember what's one less thing. Okay. And the slower train, this is the relative speed. This is the speed at which the man would see the train cross him by, right? Because the man is also moving and train is also moving, but this is going little bit faster. So this is the speed at which this is the relative speed at which the man would observe the train to go by, and it took this train how many seconds to cross him at this speed? It took this train, the faster train, 9 seconds to cross him. Therefore, this is the total distance is equal to speed into time. This becomes the distance. It is equal to speed into the time it took for the train to cross the man, which is 9 seconds. And therefore, this distance or the length of this train, this distance is nothing but the length of the faster train itself. Well, this is what the person would observe. The distance is equal to length of the faster train, and this comes out to be, if you simplify, this would come out to be 50 meters. Again, very simple, right? The only confusing thing here was a man sitting, right? So we have to only consider the man sitting in the slower train. The length of the slower train has to be ignored. Now moving on, again same concept. There are two people who are moving at the rate of 2 km per hour and 4 km per hour, and there is a train which passes them. Right? Two persons who are traveling in the same direction. So there are two people who are walking and the train is coming and crossing them. Right? It took the train 9 and 10 seconds to completely cross this. The first person, he was able to see the train for 9 seconds. The second person was able to see the train for 10 seconds, right? And this second person was travelling at 4 km per hour. The first person was travelling at the rate of 2 km per hour. So therefore, if you convert the distances, this would come out to be 2 into 5 by 18. So I am converting these speeds. 2 into 5 by 18 meters per second. The second speed would come out to be, this is 10, so this becomes 20 by 18 meters per second. This is the speed of the second person, okay, and the speed of the train we are not being given, neither the speed nor the length, so we just assume the speed to be s. What is the relative speed between the train and the person? The first person is 10 by 18, right, and this is 9. Length of the train L divided by the speed distance over time is equal to 9. Similarly, to cross the second person, this is the length of the train L minus, this is 20 by 18 and this is equal to 10. We know that 9 and 10 seconds respectively. So this is the time taken for the train to cross the first person, time taken for the train to cross the second person. So these are the two equations. We have two equations and two unknowns, so we definitely will be able to solve this, but we have to solve for L. So first thing we do is we divide this equation by this equation. So we get S minus 20 by 18, S minus 10 by 18 is equal to 9 by 10. If you solve it, S would come out to be 110 divided by 18. Notice again, I am not simplifying these terms, which is very useful because all the denominators are in 18. If you simplify it, you will get different denominators, right? So don't simplify it yet. So this is S comes out to be 110 by 18. If you substitute here, you can find out the value of L. It would again come out to be 50 meters. Very, very simple problem. Okay, just the concept of relative velocity plus the concept of the distance the train would have to travel to cross a man, right? Cross a pole, that is L, the length of the train itself. The two concepts. Now moving on, this is a slightly complicated problem, right? This is the sort of a difficult problem. So let's see how we can solve it. Read it carefully, okay, first thing, and then it's a slightly tricky problem. Here what we are being asked is the distance between the point where the fronts of the train meet and the point where the backs of the car meet. Right? We are not being asked how much time will it take to do the crossing, none of those things. We are being asked that these are the two trains, they are traveling in opposite direction, that is one thing, right, heading towards each other. So they are traveling in opposite direction, they come here and their front of the two trains are meeting at this point. Let's flag this location, okay, and they travel some more, and the backs they cross at a certain location. Let's put a flag here also, and we are being asked what is the difference, what is the distance between these two flags, distance between the point where fronts of the train met and the point where the backs of the train met. And it's slightly tricky problem, but again nothing that cannot be solved. So the first thing we do is to find out what is the total distance the trains would have to travel to make the crossing, to do the crossing. It is the sum of their length, that is the relative distance. So we do that, 0.42 plus 0.35. So we do that, that is the total distance, 0.42 plus 0.35, and this comes out to be 0.77. What is the net speed? It would be the sum of their individual speed, and that comes out to be 60 plus 50, which is 110. Right? Everything is in kilometers per hour. So my job is become very, very simple. If you simplify it, this comes out to be 7 divided by 1000 hours. This is the time it would take for these two trains to cross each other. Right? So if you notice, one thing we can say is this is the time it would take for the two trains to. So let's say that the crossing starts here in 7 divided by 1000 hour, right, or 0.0007 hour. In this much time, the backs of the two trains would be together. This is one thing we can definitely say. Right? At 0 time 0, if the front of the train is together, in this much time the back of the train would be together. Right? Therefore, the distance. Right? So let's draw this. Let's put this in figures. These are the two trains. This is one point. This is our first flag. Okay, so we have put a flag here. This is our flag. And the second flag we will put when the back of the trains are together, which is at this moment. So after this much time has elapsed, I will put a flag wherever the back of the smaller train is, right? And that would be correct because the back of both the trains at this moment is together, they have crossed each other. Therefore, I can flag the location. If I find out where the back of this train is, my job is done. If back of one of the train I can find out, my job is done. I simply find out this distance and I would be done. The front of this train after 7 divided by 1000 hours would be where? We can find that out because this train is moving. Therefore, in this much time, how much would it move? 7 divided by 1000 into, this is the, let's say the smaller train. Let's assume that this is the smaller train. So, this is 0.35. The speed of this train is, the first train has, this is the length and the speed is 60. So, this speed is, the total distance covered is 7 into 60. If you solve it, this would come out to be 0.42 kilometers. Right? 7, 5, 7, 6 are 42. So, it is 0.42 kilometers. So, this distance is 0.42. So, from this point where the front of the train met, this entire distance is 0.242, this distance is 0.35. Therefore, this distance between the points where the fronts of the train met and the back of this train is 0.42 minus 0.35 or 0.07 kilometers. And this, after 1000 hour, after that much time, both the bags would be at the same location because the crossing has been done. So, this is the location of our second flag, right, that we just planted here. This is the location of our second flag. The distance between these two flags is how much? 0.07 kilometers or 70 meters. That's the final answer. Right? So, slightly tricky, but again you have to use your imagination, right, and that is the key in such problems. If you are using your imagination, less maths, good, right, I mean good, less time. So, with that we end our class on this problems related to lengths of trains. Right? This is in the next class we would be talking about simple problems. These are again very simple problems which deal with average speed, and that would be our last class on speeds. So, average speed, the speeds that we have been considering so far are all average speeds, right? But in such problems we are given two or more spans where the speed between the speed of the two cars, of two trains, of two moving things are different, and we are explicitly being asked to find their average speed. And of course, we know that during a journey the instantaneous speed or speed at a given point is, of course, it fluctuates a lot, right? And the speeds that we have been considering so far are averaged out. But these problems specifically ask us, right, the problems themselves ask us to find the average speed instead of just giving it to us. So, if you want to understand how to solve such problems and in future many more aptitude problems, stay tuned, do subscribe to our channel. It is free, so you should definitely subscribe just by clicking the subscribe button at the bottom of this video. And thank you very much and good luck.